Okay, we're building off of, we're still on validity, and specifically construct validity, but construct validity can also be determined through criterion-related validity. So all of this validity is trying to get evidence again that we are actually measuring the construct of interest. So criterion-related validity is a set of tools that is now going to use statistical analysis, but we're no longer looking to find out if the test is reliable. Remember, we've already determined that it's reliable to be moving on to this next phase. What we're now looking at is the measure that we're under validation of, we're validating a measure, is it related to other criterion? So criterion simply means a marker or a measure or a standard. So a criterion is the standard against which a test or a test score is evaluated for validity. Criterion-related validity is how well a test measures a construct as indicated by the statistical relationships with external criteria. In other words, things that aren't the test itself. Now remember, when we're looking at reliability, we're actually comparing the test to itself. So that's what's different here, is we're now comparing the test to something other than the test. Now, criterion-related validity is almost always going to be tested with our friend the correlation. It's going to be two continuous variables, one of them our measure, and we're comparing it to some other continuous variable. Now, we also want to ask the question of incremental validity. So not only do we want to find out, is this measure related to other measures or other outcomes, we also want to know, does our new measure predict above and beyond current measures? So to what extent does a test predict the criterion over and above other variables? That's incremental validity. So for instance, if we have a general measure of depression, and we create a measure of depression specifically for returning veterans from the military, we would expect that not only does our measure have a relationship with actual depression in those people, that sample, we would also want to show that it is a better predictor, or it predicts depression above and beyond the generic measure. Because if we create a scale that doesn't have incremental validity, then why are we using it when we could just use the original scale? There are broadly three types of criterion-related validities, and actually we're going to go over four because there's also discriminative validity, but that's actually showing that it's not related to things that it shouldn't be related to. But as far as actually looking at whether or not we're actually matching the criterion, a positive criterion, something that should be related to, we have predictive validity. So does our measure predict future behavior or future performance? Concurrent validity, does it actually measure, does it actually have a strong relationship with other similar methods of measurement? So if we have a self-report survey of depression, is it concurrently related to other self-report measures of depression? And finally, convergent validity. Does it actually predict group differences that we would expect? So if we have people being rated by therapists on how much depression they have, is that different method of rating depression, rater scores, converging with our measure, a self-report of depression? And we're going to talk about each one of these in turn. So predictive validity is how well a test predicts for an external criterion. And again, the external criterion is a later measure that should be related to our measure. So for instance, a lot of times we're interested in, for example, ACT or SAT scores are a standardized test given to high school students to determine, or at least to try to determine or predict their success in college. This would be a predictive validity study. And the big thing that makes something a predictive validity study is the passage of time. We're giving our measure, and then we're waiting to gather information that should be related to our measure, but we're not getting that information at the exact same time. So the validity coefficient in this case, the R, the correlation, measures the relationship between our construct, our measure, and that external criterion. So for example, the ACT and SAT, and for undergraduates, the GRE, is all supposed to be related to college GPA, either undergraduate for the ACT and SAT, or graduate GPA for the GRE. We can't gather that information simultaneously. We have to give you the GRE or the ACT, and then we have to wait 4 years for undergraduate, 2 to 5 years for graduate school to then look to find out, do we have predictive validity? So we're predicting the external criteria. And this can also be used, for example, if we have a scale of personality. We can give a scale of personality on conscientiousness and then measure through some other method how conscientious someone is day after day after day after day. Would someone that rates highly on our conscientious scale also be rated daily in behaviors of being conscientious? That'd be another example of a predictive validity study. So the big thing here is that you're actually seeing if your new measure, the measure you're validating, is related to behaviors that you're trying to predict. So if we find this, we have strong evidence of predictive validity. So this is a pretty useful tool, and it's a pretty solid argument that we're measuring what we think we're measuring. If the ACT is supposed to predict the ability, in other words, it's measuring your ability to do well in college, if we find that it's related highly with doing well in college, we have predictive validity. The downside of this method is it does take time. So in my example here, ACT, we match each person's ACT score with their college GPA after 4 years. If we find a strong relationship in our 0.79, for instance, we've got evidence of predictive validity. We can also look at expectancy data. An expectancy table simply shows the percentage of people with a specified test score in intervals of who subsequently placed in various categories. So, for example, if we have a measure that is supposed to predict performance in an organization, and the ratings of that measure are from poor to excellent, we can actually ask then, the people that got an excellent rating, how many of them actually performed adequately in an organization? And how many didn't? So the blue bars are how many people actually were satisfactory in their production. And we find in this example, our expectancy data shows, and again, this is a predictive validity study because we first gather those initial ratings. Poor, below average, average, very good, and excellent. So we're categorizing applicants to a job into these categories based on our measure. We now have to wait. We have to wait till they work at the company long enough for us to get performance data. And if we find a chart that looks like this, we're finding further evidence that we have predictive criterion-related validity. Those people that are rated excellent, 94% of them actually were decent at their job. Only 6% weren't. The people that were average was about a 50-50 shot. And the people that were rated poorly, only 17% of those people actually performed well. 83% performed poorly. This would again be solid evidence of criterion-related validity, specifically predictive validity. Now, if we found a different relationship, if we found, for example, if you look in the middle bar, the average rating, 46 to 54, if we found similar relations like that at the poor level, at the excellent level, at all levels, we would not have predictive validity. We would basically say our measure is not related to what it's supposed to be. Our measure is supposed to be a predictor of performance. However, it doesn't really predict performance. So concurrent validity is a way to get around the problem. Predictive validity, the big limitation there is it takes time. We've got to collect our initial measure, and then we have to wait to gather actual performance or external criteria to make that comparison. And sometimes, like with GPA, that time might be 4 years long. And then we also have to try to find all those people to actually bring them back in and get data from them. Concurrent validity is a quicker and faster way to make an argument that we have validity. We are concurrently, so at the same time, comparing our measure to an established test with the same methodology. So methodology in this case means, is it a pen and paper self-report? Is it external raters? Is it a biotechnical test? Is it a brain scan? So if you're using concurrent validity, you're using the same construct and the same method, but an established method and construct to your new construct using the same method. So are the results of my pen and paper self-report IQ test similar to the existing WACE self-report pen and paper test? So again, concurrent validity is again measured by a Pearson correlation, and again, the stronger the correlation, the stronger the argument of criterion-related validity, in this case, concurrent validity. So again, what makes this different than predictive validity is we're no longer actually predicting something that we're wanting to use our test to predict. We don't want to use our new IQ test to predict whether people will do well on yet another IQ test. But we have an established test that uses the same method of data collection, in this case a pen and paper self-report test, and we want to make sure that our test is valid, measuring the same construct by looking for the relationship between the two. Another form of criterion-related validity is convergent validity. Now, how convergent differs from concurrent is convergent also is done at the same time generally. But what's different here is that we're looking for a convergent between our test methods and the same construct but a different methodology. So, convergent validity demonstrates a relationship between two methods that test the same construct. Again, it's a correlation, and again, we're looking at that criterion of R. So our actual measure of how strong the relationship is a correlation, again, 0 to 1.0. So is the test result similar to another measure of that behavior? So does self-report measures equal overt behavior? So a convergent validity study, for example, might be that we ask someone on a pen and paper rating scale to rate their conscientiousness. We get self-ratings. And at the same time, we ask all their family members to observe their behavior and rate where they think they are. So we have a pen and paper method of self-ratings, and then we have other people doing an observational rating. We compare those two. They're the same construct, basically the ratings of your conscientiousness, but they're coming from two different methodologies. One self-ratings, pen and paper, the other ratings, and they're basically just giving that information verbally. Again, we find a strong relationship. We have further evidence of the idea that this is a valid measure. The final way we can make an argument for criterion-related validity is actually to make an argument that our measure is not related to things it shouldn't be related to. And this is referred to as discriminant validity. So discriminant validity demonstrates a lack of similarity between two measures that purports to measure different constructs. So is the test result similar to the results of a test that measures a different behavior? If so, that's an argument against validity. So we want, for example, if we have an anxiety measure, we wouldn't want it to be highly related to a depression measure. If I've got a scholastic aptitude test like the ACT, I wouldn't want it necessarily to be related strongly to social economic status. If it was, that means I'm capturing something that's outside of the construct that I'm interested in. So this is a case where we're actually hoping to find a small relationship or no relationship. So putting this together a little bit, when we're looking at criterion-related validity, we're looking at concurrent validity. And in that case, we're asking, does our measure of a construct highly relate to other measures of that construct that use the same method to measure that construct? Two pen and paper tests. Concurrent validity or convergent validity, does our measure compare to other measures of the same construct that use a different methodology? And finally, discriminant validity, does our measure not highly relate with different measures of using the same method or different method? So, taking these concepts together, that leads us to our next concept. The multi-trait, multi-method matrix, or MTMM, is a method devised by Campbell and Fisk in 1959 that measures convergent, concurrent, and discriminant validity all at once. 4 measures are generally compared in a multi-trait, multi-method matrix. And what we're comparing, and I'm going to walk you through this, but basically we're combining everything we've talked about into one study at this point. So first, we're going to have a pair of variables that measure the same construct, so A and B. We're going to have another pair that measures the same construct but different from A and B. So you always have to have 2 constructs, different constructs, to use the multi-trait, multi-method matrix. For example, I'm going to use the example in this case, depression and anxiety. So depression is A and B. Anxiety is C and D. Then, one pair uses the same method. So A for depression and C for anxiety are both self-report measures. The other pair uses the same method to the measure, but one that differs from A and C. So B would be a clinical psychologist rating of depression, and D would be a clinical psychologist rating of anxiety. So you're going to gather this information all from individual participants. So every participant in this study will fill out a self-report measure of depression, A, a self-report measure of anxiety, C, have a clinical psychologist rate their depression, B, have a clinical psychologist rate their anxiety, D. So the multi-trait, multi-method matrix then assumes that A and B should be similar. They're measuring the same construct with different methods. That C and D should be similar. They're measuring the same construct, in this case anxiety, but with different methods. A and C are different constructs, but the same method. So there might be some relationship. Basically, people who take self-report measures tend to respond in similar patterns. I've mentioned in class that when I take a 1 to 5 scale, I rarely use the 1 and the 5. So if I'm taking a depression scale and an anxiety scale, I'm probably going to still be a little similar in how I respond to those, even if I'm depressed but not anxious. So A and C should be dissimilar, but not necessarily have no relationship, because A and C are the same method, different constructs. Remember, A is self-report depression, C is self-report anxiety. B and D should also be dissimilar, because in that case, there should be some relationship, because these are the clinical ratings, and that rater probably has some similarity in how they rate things. But again, B is the clinical rating of depression, D is the clinical rating of anxiety. Now, A and D, different constructs and different measures. So a self-report on depression and a clinical rating of anxiety should be very different, very little relationship. And same with B and C. So when you put all this together, you're going to get information on concurrent validity. So basically, you're going to find, convergent validity. So converging A and B is convergent validity. And then you're also going to get discriminant validity, looking at the different constructs. So the similarity and differences are determined by the strength of the correlations between the two measures. So let's take a look at how this actually plays out and looks visually. So here we have an example of, again, how this all plays out. So the R's are, generally speaking, what we're looking at there is how the various methods interrelate with each other. And they should be the very strongest relationships. The T's are the traits themselves. So for instance, if we look at that first big T, method 1, trait A, by method 2, trait A, that's where we're comparing the same construct measured by different measures. That should be our second highest, and that actually is convergent validity. Same construct, different methods. The M is the method variance. So for instance, method 1 trait A by method 1 trait B, those are different constructs, but they're both self-report. Much like method 2 trait A by method 2 trait B, that's our other M, method variance. That again, we should see it be fairly high, but not as high as the others. And finally, H is often referred to heterogeneity or the difference scores. That's where we find a different construct and a different way to measure it, and we should see those as the lightest. So what we're looking for a strong argument of construct validity, specifically criterion-related validity with this method, is that the R's, the relationship between the same kind of constructs and the same methods of measurement, should be the strongest. Those should be the largest numbers. Those should be the highest correlations. The next highest should be the traits. Same construct, different way of measuring it. Those should be the next highest correlations. And again, highest correlation we'd expect here is 1.0, lowest would be 0. Next, we would expect some relationship based on purely the method you're using. Self-report and self-report regardless of the construct. So these again should be lower than both the T and the R boxes, but still higher than the final box, which is H. Different method, different construct. If that's the pattern you find, the R boxes, traits, the same traits, same methods, are the highest, the trait boxes are the next highest, the M boxes are the next, and finally the lowest is the H. This makes a very strong argument for both convergent and discriminant validity all in one study. If you find any other pattern, that's a problem. So let's go through with an example here that actually shows what we're looking for. So I've replaced the R, T, M, and H with actual scores. So again, a self-report measure of depression by a different self-report measure of depression, very highly correlated. A self-report measure of anxiety by a different self-report measure of anxiety, very highly related. An observation of depression by an observation of depression, highly related. Those red boxes, that main diagonal, are my highest numbers. The lowest number there is 0.87, and that's higher than any of the other colored boxes' scores. The next thing I want to make sure is that my green boxes, in this case my trait variance, same construct, different method of measurement, is the second highest. In this case, 0.75 and 0.68. Again, we're finding what I'd expect to find. Finally, that method variance. I expect some method variance. This number can be fairly high. It just needs to be lower than the red diagonal or that green diagonal. In this case, pretty high. It means that a fair amount of variance is being explained just by people responding similarly on self-report or similarly on observations. But it's still good enough because it is lower than the red and the green boxes. And finally, I find those low values in the H boxes. When I look at self-report by anxiety on observations of depression, I see a 0.07, very low. So this is an example of a multi-trait, multi-method matrix box that is strongly arguing for criterion-related validity, both again convergent and discriminant. Here's an example that's not quite as convincing. It's still better. It's still got a little bit of what we're looking for, but we're definitely starting to see some issues. So in this case, the red boxes are still the highest. So the very lowest red box is 0.75, and that's still higher than the other boxes. But when we look at trait, 0.46 and 0.51, that's actually lower than the method variance, which means the type of method you use, self-report, is more related to itself than the actual constructs. So depression by self-report, by depression by observation, is 0.46. But self-report depression by self-report anxiety, same method, different construct, is actually more highly related. This would be an argument that we've got a problem. The methods are accounting for almost equal, if not more, variance than the actual traits. That green boxes, those traits, always need to be higher than the methods for us to make an argument. This would argue that we might have some validity, so we're finding that convergent self-report depression by self-report depression. Actually, in that case, that's concurrent. Two different measures of the same actual methodology. We're not finding concurrent. In fact, we're finding evidence that concurrent is weaker than just the methods themselves.